Starship is extremely fundamental. So the holy grail of rocketry or space transport is full and rapid reusability. This has never been achieved. The closest that anything's come is our Falcon 9 rocket, where we are able to recover the first stage, the boost stage, which is probably about 60% of the cost of the vehicle, or of the whole launch, maybe 70%. And we've now done that over 100 times. So with Starship, we will be recovering the entire thing. Or at least that's the goal.
Right.
And moreover, recovering it in such a way that it can be immediately reflown. You just refill propellants and go again. And this is gigantic. It just as it would be in any other mode of transport.
And the main design is to basically take 100 plus people at a time, plus a bunch of things that they need to Mars. So first of all, talk about that piece. What is your latest timeline? One, for the first time a Starship goes to Mars, presumably without people but just equipment. Two, with people. Three, the sort of, okay, 100 people at a time, let's go.
Sure. Well, and just to put the cost thing into perspective, the cost of the expected cost of Starship putting 100 tons into orbit is significantly less than what it would have cost, or what it did cost, to put our tiny Falcon 1 rocket into orbit. Just as the cost of flying a 747 around the world is less than the cost of a small airplane, a small airplane that was thrown away. So it's really pretty mind-boggling that the giant thing costs way less than the small thing. So it doesn't use sort of exotic propellants or things that are difficult to obtain on Mars. It uses methane as fuel, and it's primarily oxygen. It's sort of roughly 78% oxygen by weight. Mars has a CO2 atmosphere and has water ice, which is CO2 plus H2O, so you can make CH4, methane, and O2 oxygen on Mars.
Presumably one of the first tasks on Mars will be to create
a
fuel plant that can create the fuel for the return trips of many Starships.